going to be teaching you about the science and electrostatics behind ion propulsion engines, which are used to accelerate spacecraft.
Ion thruster, we're going to start by explaining the basics of charged particles within magnetic plates. So if we have a positive particle, it is going to be attracted to the negative side of the plate and repelled from the positive side of the plate. So if it's being thrusted forward, it'll make a curved motion towards the negative side. Now, vice versa, if we have a negative particle in the middle, it'll be attracted to the positive side and repelled from the negative side. So if it's being thrusted forward as well, it'll go towards the positive side. Now, if we have a neutral one that neither has a charge, and it's just neutral in the middle, it is not going to be attracted to either side of the magnetic field. It's just going to go straight or stay in limbo, depending on the force that it's applied to.
So now we're going to be talking about the cathode ray tube, which was created by J.J. Thomson. It's essentially a big tube of glass that is sealed and has all of the air sucked out of it. So in the glass we have two pieces of metal which are oppositely charged by a power source. So this metal shoots a cathode ray through this oppositely charged metal through the entire tube. So the next thing J.J. Thomson did is he went in with two oppositely charged plates, one being positive and one being negative. And when the cathode was shot from this piece of metal, we saw that it started to bend towards this side of the tube. And this showed us, because we know that opposites attract, that this ray must be made of tiny negatively charged particles, which we call electrons. From this, we can also go into this, which we explained earlier, that if an electron is shot from a negatively charged piece of metal, it's going to be pulled towards a positively charged piece of metal, and thus this is shot through our electron tube. And this is applied in our ion thruster, which we'll now explain, which this is our source of electrons in that.
Mackenzie talked about, we have a cathode ray gun, which is going to shoot electrons, that's for the bad E, electrons into our ion thruster. However, because these are negatively charged, and we want them to be positively charged so they're attracted within the plates on this side, we're going to shoot xenon particles at the electrons, and these are going to combine to be a positive particle, which then allows them to be attracted once they're in the plates. However, that's going to be discussed in the next segment.
So this positive particle now has a velocity from this cathode ray gun towards the plates. But as you can see, this plate over here is positively charged, so there's going to be a force counteracting this velocity, but the velocity from the cathode ray gun is strong enough that it can overcome the force of the plate, where this positive particle can now diffuse through the plate into the middle of both of these mesh plates. And once it's in the middle here, it's now attracted by this negatively charged mesh plate, which has extreme magnetic force. And this magnetic force forces this particle to push through the mesh plate and out into the open air.
So now this particle comes out of the ion thruster, and this is a positive charged particle, and we don't want this particle to go back because these plates are negative charge, so it will do this. Because we don't want that, we add a cathode ray gun here with a negatively charged plate on top and a positively charged plate on the bottom, and so this will shoot electrons, and since the positive charged plates here, it will bend this way, intersecting our positively charged particle here. And when they intersect, this particle will be neutralized, so it's not going to have any charge, and since it doesn't have any charge, it will not be affected by this plate, so it will just go this way.
We've described our ion thruster. You can see that if you had many of these particles flying out in this direction, all the force of those particles moving at that high of a velocity is going to push this rocket in this direction. And that's how rockets are going to start being used in the future.